everyone, my name is Miss Sarah and today we're outside of the library to do an episode of STEAM Club. We're going to be making elephant's toothpaste. If you're going to try making elephant's toothpaste at home, here are the things that you're going to need. First, you'll need an empty water bottle, some measuring cups, a packet of yeast, hydrogen peroxide, dish soap, and some warm water. You can also make this more fun by coloring your elephant's toothpaste with food dye, but that's totally optional. Also, make sure that you have a space outside or somewhere with tarps or newspapers laid down because we're going to make a mess. So the first step to making elephant's toothpaste is to take half a cup of hydrogen peroxide and pour that into your water bottle. Next, we're going to take a big squirt of dish soap and put that in on top of our hydrogen peroxide. And then swirl that all around so it gets mixed up. Next, we're going to take our packet of yeast and 3 tablespoons of water and mix them together. Now this packet of yeast is about 2 1/4 teaspoons of yeast, but if you have a different size package, you're aiming for about 1 tablespoon. But this is a little bit less than that, and that's just fine. I preheated this water earlier, and when you're heating up your water, you want it to be warm but not hot, because if your water is too hot, it'll kill your yeast. And again, you want 3 tablespoons of that. Now I'm going to stir up my yeast and my water for about 30 seconds until it's nice and foamy. Okay, and now for the optional step, I'm going to add some food coloring to my water bottle so that when this comes out of the bottle, it gets colorful. If you want your elephant's toothpaste to be all one solid color, you can just add a couple of drops of the food coloring into the bottle and then swirl it up. But I think I want some stripes in mine, so instead, I'm going to kind of tilt it and put the food coloring right on the edge of the opening. You see, so that when it comes out of here, it's going to capture that and make stripes. Now that we're all done setting up, I'm going to move this water bottle onto the ground because, like I said earlier, this is going to get messy and I don't want my table to be sticky afterwards. Now it's time to pour our yeast mixture into our bottle. Now when you do this, make sure not to put your eyes right over the opening of the bottle because it's going to come shooting out and you don't want to get the hydrogen peroxide in your eyes. All right, I'm going to pour this and then I'm going to back up so I don't get messy. Oh no, my bottle fell over here. The foam is warm to the touch as it's touching my fingers. If you want to try it at home, come feel how warm the mixture is. It's okay to touch, just make sure you wash your hands after. Do you see how the mixture is foaming out of the bottle and it's creating those stripes as it comes down from the food coloring we put in there? Look at all that foam. That's why we did this outside. Wow, wasn't that cool? Now that we're done with the experiment, I'm going to take y'all back into the library and tell you how that happened. Now, I bet y'all are wondering, how did a bottle of just soap, hydrogen peroxide, and yeast turn into an explosion that foamed all out of the bottle? Well, to answer that question, we need to talk a little bit about atoms and molecules. So first, what's an atom? An atom is the basic building block of all things in the world. So every single thing, including me and you, is made out of atoms. On the screen, there's a picture of a single atom, and this is oxygen. And you can see that there are different parts of it, like the nucleus here at the center, and then different protons and electrons circling the outside. Here we're going to represent our atoms with a little soup block. So this soup block is going to represent oxygen. Next up, let's talk a little bit about elements. Now, elements are things that are made out of only the same type of atom. So in this case, if I put these two oxygens together, we get O2, which is the type of air we breathe. You see, atoms want to join together. Sometimes they have unstable bonds, and forming together like this helps them be more stable, meaning they don't break down as easily. You might have seen this in some of your science classes. This is called the periodic table of elements, and it has all of the elements that we know about listed on here. So over here we have oxygen, and over here we have the other type of atom that we're going to talk about today, which is hydrogen. And I'm using my silver soup to represent a hydrogen atom. So different types of atoms can also form together with each other to form molecules. So molecules are when different types of atoms join together. One example of this that you might be familiar with already is H2O, which is also known as water. Now you might be wondering, how is this relevant in this case? Well, hydrogen peroxide is also known as H2O2, and that would look like this soup here, where we have 2 oxygen and 2 hydrogen. And over time, this will start to break down. And as it breaks down, and as all the other hydrogen peroxide molecules start to break down, these atoms come together to form H2O, like we have here, and O2. So again, we have one hydrogen peroxide atom here with 2 hydrogen and 2 oxygen, and as that breaks down, it turns into water and oxygen. But this happens really slowly, and the hydrogen peroxide that you buy at the grocery store is always stored in these dark brown bottles because the exposure to sunlight can make this process happen more quickly. And we don't want this to happen, because then our hydrogen peroxide wouldn't be useful anymore, because it would just be water and oxygen, and it would no longer be useful for doing what hydrogen peroxide is supposed to do, like cleaning wounds so they don't get infected. But we can also make this happen faster. And so to do that, we need something called a catalyst. A catalyst is anything that makes a chemical reaction happen faster without changing the process. In our case, our catalyst was yeast. So yeast is something that you might use for baking, but what you might not know is that there is a chemical in it called catalase. And this chemical happens to make hydrogen peroxide break down faster. So when we add the yeast to our hydrogen peroxide, the yeast acts as a catalyst, and it causes our hydrogen peroxide to break down into water and into oxygen much faster. And if you've ever at home taken a straw and blown air into water, you'll notice that the air bubbles, they want to come out of the water. They rise up out of the water and they cause the water to bubble. But this would happen pretty quickly if we just added hydrogen peroxide and yeast together, because the bubbles would just be able to easily escape, and maybe our mixture would bubble a little bit, but we wouldn't get that foam. But by adding dish soap, we're able to create foam. And that's because dish soap is a great way of making bubbles. If you've ever washed dishes, you've probably noticed a couple of little bubbles floating out of the bottle. So when we add all of these things together, our hydrogen peroxide and our yeast react. There's a chemical reaction, and that creates air bubbles. And then those air bubbles get trapped inside the soap, and that creates foam. So lots and lots of foam coming out of our bottle, creating something that I think looks a little bit like toothpaste, and enough of it to be able to brush the teeth of an elephant. In addition, this is an endothermic reaction, and that means that when it happens, it creates heat. You might remember that when I touched the foam, because my bottle fell over, I noticed that the foam was warm, even warmer than the warm water that I had put into the bottle. And that's because the yeast catalyst also creates heat. Well, thank you all so much for watching this month's episode of STEAM Club. I hope that you learned a little bit of something about atoms and molecules, and maybe learned how to do a fun science experiment that you can try at home. Join us next month and we'll have a brand new science experiment for you to try out. Thanks so much for watching. Bye!